Okay, so thank you very much for joining us at this panel discussion about Tianwen-1 mission. So I think most of you are aware of the launch of the mission this afternoon by China. So this month will be an interesting month as there are totally three missions will be launched by the end of this month, and our dream to Mars is getting closer than ever. So first of all, please allow me to introduce our panel will be an interesting month. So first of all is our Dr. Chong Hon Yu, which is our totally president of Astronomical Society of Penang, and the second one, Mr. Lai Hong Jun, is getting closer, who is technically, first of all, a rocket scientist. Am I right? So our panels will be an interesting one. So first of all, the third one, Dr. Chong Hon Yu, which is our totally David To, Astronomical Society, who is amateur rocket enthusiast, and I think he is our future rocket scientist as well. So first of all, I'd
Mr.
like to
Moderator,
invite
please explain, introduce
Dr.
yourself
Chong.
also. Mr. Moderator, introduce yourself also.
Okay. Sure. Okay. I am Chai Hong Shen. Basically, I'm a rocket enthusiast as well. So without further ado, please let us invite Dr. Chong Hon Yu to give us a little bit of background information about this mission Tianwen-1.
So now it's 8:35 p.m. All right, July 23rd on a Thursday. It's already 7 hours after the launch. The launch of what? Our Tianwen-1 Tianwen-1, or they call it 火星1号 Mars 1, and we were very excited. So later on, Hong Chuan will show you the delayed version of the launch. So it was launched at Malaysian time 12 hours 41 minutes 39 seconds. All right, and we saw the whole launch, and of course it was successful. And later on, Lai and David will explain more details about the rocket itself. All right, so now where is it now? Sorry guys, it is still on the way to go past the moon. Remember, with advanced rocket technology, 5 days to go to the moon. So now it's only half a day, so it's only 1/10 the distance to the moon. So what is it doing? It's free falling towards Mars, all right, and it should arrive Mars in the February next year, all right. So I pass over to our other speakers. Can I hear you?
Your mic is disabled.
Yeah.
Okay, sorry. Yeah, so maybe Mr. Lai can explain a little bit in details about the technical aspect of the mission.
Yes, so let's start with some overview of the whole mission, I think. So firstly, this mission was launched this afternoon during, I think, most of us, the lunchtime, around 12:40 p.m. So it's launched by using the rocket called Long March 5, and this Long March 5 is slightly different from the Long March 5 we have previously. The earlier Long March 5, the previous Long March 5 is a Long March 5B, which is launched in May this year, which is 2 months back. And today we launched is the original Long March 5. So it's a two and a half stage rocket. So this mission, this Tianwen mission, we have 3 objectives. The first objective, of course, is launch from Earth and then orbit the Mars. So the first is the orbital mission. Second is the landing mission. And the third one is the patrol mission. That means it will move around. You have a rover move around the Mars to carry out some scientific studies on the geography and some physical characteristics of Mars. So the first question I'd like to discuss a bit is why Mars? And as our chairperson just now mentioned that we have actually three 3 Mars mission this month, end of this month. Previous, I think, just 3 days back on the 20th of July, the Arab have launched the Hope Mars mission. Is an orbital module from Japan. And then today we have the Tianwen mission launched using Long March 5. And also in a week time, hopefully in a week time, everything goes smoothly. The America will also launch the Perseverance mission to Mars. So one question is why everyone is launching on this time, launch to Mars, going to Mars this time. And the next question is why Mars? So let's discuss a bit on this. So first, why Mars? Mars is the fourth planets from Earth. So we are going to Mars, but we have another planet which is nearer to Earth, which is the Venus. Why we did not plan to go Venus this time, but directly go to Mars? This is one of the topic which many of the Chinese outreach project they did ask is Venus is actually nearer to Earth compared to Mars. But then why we skip Venus and directly go to Mars? The answer is actually quite simple, because for Venus, to go to Venus is not easy compared to Mars. Okay, there are a few things that we need to solve. The first issue for Venus is the atmospheric pressure. In Earth, we are enjoying with 1 atmospheric pressure, which we are used to it. But the atmospheric pressure in Mars is about 90 times stronger than Earth. So the first thing you have to go through is high pressure. And then the second thing is in Mars, the atmospheric content, most of it is carbon dioxide and nitrogen. So it's very acidic. So it's not suitable for life, and it's not good to our lander or our whatever satellite already going to the Venus. The third one is the temperature. The surface temperature on Venus is very high. It can go up to 460 degrees Celsius, which is I think about 15 times, not 15, I think 12 to 15 times the temperature on Earth. So it's not fun going there. And also another thing is, we go to Mars, the mission lifetime calculate by Mars days. So when they go to Mars, we have 90 Mars days. For example, this Tianwen mission, it will work for 90 Mars days. But then imagine if you go to Venus and you said you want to work for 5 Venus days, that means you have to work for 5 years, because 1 Venus day is about 243 Earth days. So you need to control or have communication with your lander or rover on Mars, on Venus. For it to work 1 day, we have to work 243 days over here. So it's not fun as well. So that's why, after considering all this, so they decided to skip Venus and directly to go to the Mars mission. So this is about a little bit background on why this time the Penang mission directly to Mars instead of.
Can see me now, what?
Yes. And another interesting thing is this Tianwen mission itself. The whole satellite consists of 3 parts. The first part is the orbiter module. The second part is the landing module. And the third part is the rover. So there are six missions. Okay. So the first one is to study geography of the Earth, of the Mars. All right. Second is to analyze a bit on the material of Mars. All right, on the soil of the Mars. Okay. The third one is to study the sublayer. Okay, sublayer of the Mars, and because previous mission shows that we have underground water in Mars. So this time, they are planning to study the sublayer of the Mars and see whether to further explore whether there is water and whether there's life or intelligence life in Mars. And the fourth one is for the orbital mission before they land the lander and the rover. Sorry. The orbital mission have two landing spot. Okay, it's actually on the northern region of the Mars. So the orbital module will also study which is the more suitable spot to land the lander, and the landing spot is previously the sea of the Mars. So the land is more flatter. All right. And also to study the atmospheric condition, the weather in the Mars. So this is about the missions of this Tianwen mission. And for the rocket Long March 5 itself, one interesting thing for this time mission compared to previous mission is this time the biggest challenge for this rocket is it have to reach the escape velocity of the Earth. Maybe we can have a little bit interaction with our audience, which is maybe we can see whether our audience know whether how much is this Long March 5 rocket need to achieve to escape from the effect of gravity of the Earth. So maybe you all can have a little bit comment on the comment section, see whether you all know what is the velocity the rocket need to achieve to escape from the gravity of the Earth. Previous mission, we send satellites to LEO orbit. So the velocity is about 7.9 kilometer per second to maintain in orbit. But this time we have to escape from the velocity, from the gravity effect of the Earth. So the velocity should be higher. But how much is it? Let's give it for a short while and see whether anyone's can give the answer in the comment section. And this is a brief introduction about the whole mission. So maybe I give a little bit translation in Chinese because I might speak smoother in Chinese. 所以大概情况就是这样，就是这次天问的这个任务呢，就有3项，就是绕、落跟巡啊。首先就是从地球发射到这个火星之后，先绕着火星绕了几圈，然后再让我们的着陆器实行一个软着陆，着陆了之后会放出这个火星车啊，这个火星车离开了这个着陆器之后，它就是一个独立的个体啊，在这个进行第3个任务就是巡，就是在火星的表面进行一些巡视。那么这个任务呢，为期就是90个火星日啊。那么一个火星日差不多就是地球1天多一点，就是24个小时39分钟左右。那么刚才也提到一个问题，就是为什么直接就去到火星，不去比较靠近的金星呢？就是因为金星在金星这个环境比较恶劣啊。首先它的气压比较高，第二个呢就是它经常下酸雨啊。在地球上搞浪漫的话，就是一起去看流星雨，在火星就看硫酸雨啊，就是一个这样的情况。那第3个呢就是这个温度啊，火星的表面温度也非常高，还有时间啊。火星一天的这个就这个金星的温度比较高，然后金星的这个时间啊，就金星过一天就243天啊，在地球就过了243天。所以你想一下，假设说你要在这个金星上啊，让你的这个着陆器干5天啊，就运作5天的话，你就在地球上你就得搞好几年是吧？搞死了都搞不好是吧？所以大概的这个就是为什么直接去到火星，因为火星的这个时间比较好 那么这些火星呢，有差不多6个科学任务啊。第一个就是对火星的这个地貌物质成分进行一个探测和研究，然后对火星的土壤的厚度、成分和分布进行一个探测，还有就是对地下水的分布进行一个探测，还有就是火星地区的详查主要就是这个在绕的时候，就是我们的这个环绕这个卫星在绕着这个火星的时候呢，可以帮助我们的先选定一个这个，我们现在就是目前的情况呢是有两个候选的这个着陆区现在就是绕的时候会选定一个着陆区，还有就是对火星的这个物理场，就是火星的磁场还有内部结构进行一个探测，还有火星的气候和大气进行一个探测。所以这个就是大概整个天问的任务所以给大家做一个简单的了解那么我就把这个交回给主持人
Okay, thank you, Lai. So from the comment section, I saw there is. I think there could be one relevant comment, but the question doesn't seem to be clear. The person, the commenter named or you her asked, is it either as a year? But I'm not sure which part he or she is referring to. But do you have any idea about this?
Not very clear the question, Hong Chuan. The year, the what again?
Yeah, the question is just like it is considered as a year. So I'm not sure about that. So maybe if you are the commenter, you can make a clearer question so that our panel can understand what you want to ask. So so I read about that in this mission, the rover is destined to be landed at Utopia Planitia. So, is there any particular reason for them to land on this area? Because previously it seems like it was planned to be landed on another location.
Now you try first, then I try.
Okay, so as I did mention just now, which is there are 2 landing spots not fully confirmed yet which will be the final landing spot, but the orbital mission will carry out have a closer look on the landing spot before it decide which is the final spot. But the current planned landing spot is previously known as the sea of Mars. So 就是它是火星的海，所以它的那个地面会比较平，就比较平缓。That means the landing location is like a more flattened surface.
It's flatter?
So sorry.
No, continue. Sorry.
Yeah, it's more flat, so it's better for first time landing. Okay, compared to if you land on the hill or land on a valley, that will be more challenging. But then since this is the first time, so a flatter surface will be a better options for the mission.
So allow me to try to answer that. So actually both Lai and the questionnaire are correct. It was like this. Earlier, the Chinese CNSA, China National Space Agency, planned to land on 2 other places on Mars, like what we asked for. But sometime last year in September, there was a big, I think, space conference in Geneva, in Europe. So when the Chinese presented the landing spot, so there are a lot of discussion. So the Chinese changed from the earlier 2 proposed site to Utopia Planitia, right? And by the way, Utopia Planitia is where Viking 2 landed, 1970, 75. I was a USM student that time. Utopia Planitia. But what Lai said is correct. So this Utopia Planitia previously was a very old lake. And remember, they are confirmed with the what you call Spirit and Opportunity mission in the early 2000s that Mars had liquid water billions of years ago, 4 billion years ago. So the big question for Mars today is, where did the liquid water go? So now Europa Planitia last time got oceans of liquid water. So maybe some of the evidence of past life, or maybe even currently living organisms, may still be in Utopia Planitia. So that's why they want to go. Of course, they are all together 4 successful American rover. All right, Sojourner 1997, like a microwave oven. Spirit of Opportunity early 2000, and the recent Curiosity. So there are many places. So I'm sure the Chinese will pick a place which is different from where the American landed. But of course, we understand that the main mission objective of China are a few. One is to see whether there are conditions on Mars suitable for life, or even whether there is still living life on Mars. And of course, the other one is study the geology, right? Study all other aspects of Mars. Yeah. Okay, pass over to David.
Maybe David can have some comments on this.
I'm actually not too sure what to talk about.
You can explain about the Long March 5, Y4 rocket, the details lah.
Oh, like, I have a question for you.
Okay.
Yeah. In the photos, you can see the Long March 5, there's a rocket straight, and then you can see the boosters are like, the flames of the booster are pointing towards the outside rather than straight down. Why do they?
You mean the flame is not exactly straight down, is it? Is
Yeah,
slightly
it is towards the
outwards, is
outside.
it?
Yeah.
In fact, they actually point the nozzle of the rocket engine outwards. It's not directly straight down, you know.
Is it for stabilization purpose?
There is a purpose for stabilization also, but then the science behind, I'm not very sure on that. But then, in fact, stability is one of the reason for the rocket itself to maintain on it, because if you go straight down also, if you go directly straight down, when it come up from the nozzle, it will expand, you know. So
Yeah.
when the exhaust is one of the reason I can think of is to avoid the interference of the wave, because when you exhaust from the nozzle, the rocket engine is actually hypersonic speed, supersonic speed, so you have shock wave. So to prevent the interference of the shock wave, so this is one of the reason they slightly tilted the rocket engine slightly outward, so that to prevent the interference of the exhaust of the exhaust with the main stage.
So David, you want to continue before I give my long explanation?
John, you can go.
Yeah.
You can start
So,
your
Mr.
long
Moderator, allow me to explain.
explanation.
Okay. So,
Sure,
of
Doctor.
course, mankind has been always looking towards Mars for many years. Of course, before man invented telescope, they saw all the planets, from Mercury to this Jupiter. So Uranus, Neptune, Pluto was not discovered, but it was in the 19th century. There's a very rich American businessman called Lowell. All right. So he built his own. He was actually from Massachusetts in Northeast USA. He built an observatory in Arizona, Flagstaff Observatory, and where he spent many years to observe Mars. And he was the one who started the crazy thing called got alien on Mars. Or canals, long line, dark lines. And he said he saw the canals. So there was a so-called Mars fever in American newspaper, British newspaper, European newspaper, Australian newspaper, New Zealand newspaper, Canadian newspaper, the Western world, all over. They say, got water, got canals on Mars, surely got life. So that was the problem. So that's why man is always keen to go to Mars. So when I was very small, in studying even in a secondary school in KL, my hometown, we were keen to go to Mars. But sorry, now the interest for life in the solar system is not only Mars. For example, the moons of Europa, what they call Ganymede and Callisto, you have a thick layer of ice on this moon, and below the ice, you have liquid warm water. So there's most likely NASA is very keen, for example, to go to Europa, layer of ice, drill through the ice, and go down to the water below, and maybe drop in a submarine to study it. So now Mars is not the only place, but Mars is still attracting man's interest because got what? Got liquid water. It's confirmed by spirit and opportunity. So that's it. Huh? So that's why Mars is still attracting the interest of human beings. Okay, the other one is the Chinese actually what they call they want to tumpang, piggyback. I think 2011 or 12 on the Russian Phobos Grunt mission. The Russian want to send a mission to Mars, and on it you have one of the piggyback tumpang passenger is the Chinese Yinghe what they call orbiter. But the mission was not successful because the moment they launched from the Earth's surface in Baikonur, it went to Earth's orbit, and just orbit insertion to Mars, they lost signal. So the whole mission failed. That means the piggyback, the tumpang passenger also cannot go. So after 2012, the Chinese, they reorganized their policy. They started their own mission to go to Mars in 2016, only 4 years. So in 4 years from nothing, they came up with a mission, Tianwen-1. So that means in 4 years they did it. So now they have this mission that goes to Mars, and it's very ambitious because you see, no country in the world have done it. First mission where you have the orbiter that will orbit the Mars, and the lander, all right, and the rover all in one. The previous mission are like that, you know how the Americans and Russians went to Mars from the Earth. They send a rocket to go to Mars. So the first thing can happen is even before going to Mars fail. It has happened before for Americans and Russians. Another one is they send from the Earth on the way to Mars, fly by. The first mission to Mars is not land on Mars, no, not orbit, fly by. Because the technology in the 1970s not so advanced. Just fly by Mars, and after fly by what happened? Fly into the outer solar system. So the first few mission, American Russian is fly by to Mars. Then the later American mission is orbit around Mars. Right? And the later one is, of course, the land on Mars. So I think the first lander of Mars was a Russian mission. Right? Then later on, the Americans also landed. All right. So they always say that Mars is graveyard of space exploration. More than 14 missions to Mars, more than half of them failed. So remember, they always say, you can read in even the textbook, for saying Mars is an American planet. The Russian only once landed only. So most of the successful missions are the Americans one. So now what? There's a race going on, America and China, to go to Mars. All right. So that's it. So now a bit about the technology of this Chinese Tianwen-1 mission to Mars. Of course, they use the most powerful rocket they have, our Long March 5, all right, Y4. What do you mean by Y4? Because the Long March 5, they follow the system of naming is Y1 means Long March 5 first launch, 2016. So the second Long March 5 is Y2, Y3, Y4. So this is the fourth successful launch of Long March 5. But Long March 5 got a derivation, a variant called Long March 5B. So the Long March 5B also Y1, Y2, Y3, Y4. So this Long March 5, Y4 is the fourth mission of the Long March 5. What about the Long March 5B, Y5 will be the one who send the Chang'e 5号, the fifth Chang'e mission to go to the moon end of this year, land on the moon, and later on blast off from the moon and a sample return mission back to Earth. That's the Long March 5, Y5 end of this year. So this Y4 mission to Mars is with this, as I said, orbiter, lander, and rover all in one. And remember, the Indians have beaten the Chinese, Remember, we followed. 2013, they launched from India the Mangalyaan, the Indian orbiter to go around Mars. And on the first attempt, they succeeded. So the Indians most successful in the Mars mission. No need flyby. Straight first mission to Mars was orbited around the Mars with fully all their technology succeeded. So if China can orbit around Mars, land on Mars with a rover on Mars, 3-in-1, nobody has done before. So it's not easy, So I'm sure the Chinese space agency people, will weigh all the risks, so they know it's not easy, all right. So a bit about the trajectory of this Long March, this Tianwen-1 mission is that, remember, why do they launch Malaysian noon time? You think carefully. You can explain. It's like this. They will not send the rocket to Mars like that. Previously, they can do lah. Like for example, when you go to the moon and even previous mission to the other outer planets, they will launch from the Earth's surface into a parking orbit around the Earth. Parking orbit around the Earth, and they check all the system go. If all work, then only they fire the rocket to insert it to go to the Mars or Jupiter and beyond. But this one no. So the launch at noontime Malaysian time. If you look carefully, that imagine you look at the clock, 12 o'clock. So imagine now it's noontime Malaysian time. That means imagine you are standing at 6 o'clock. All right, 6 o'clock, and vertically above your head is the sun. That means 6 o'clock, you go down below 6 o'clock is the sun. All right. So when they fire it at 12 noon, the rocket will go. The rocket will go anti-clockwise. From 6 o'clock, it will go to 5 o'clock, and you go to what they call on the clock face to 3 o'clock. So 6 o'clock vertically down means 12 noon. And then when you go to 3 o'clock, means somewhere in Hawaii, Hawaii. And that one it will be, so on Hawaii, if you look towards the east, what's it? That's towards the outer solar system. So that means they must launch in the noontime so that when they make a quarter orbit around the Earth, so after that, the second stage of the Long March 5 will boost the Long March lander, orbiter, and rover to the outer solar system towards Mars. So that's why they must launch at noontime. All right, that's it. And then remember, there's another thing is we always know from our astronomy course that what is the orbital speed of the Earth around the Sun? So the Earth orbits around the Sun at a velocity of 30 kilometers per second. That's more than 100,000 kilometers per hour. What is the orbital velocity of Mars around the Sun? 24 kilometers per second. So in other words, you want to send a rocket from the Earth, which is orbiting the Sun at 30 kilometers per second, to land successfully on Mars at 24 kilometers per second. You must slow down the speed of the rocket from the Earth such that it will match the orbital velocity of Mars of 24 kilometers per second. So basically, traveling from Earth to Mars, you have to reduce the velocity such that when you reach Mars in February next year, the speed of the rocket when entering the Mars atmosphere will be 24 kilometers per second. You must match it. Then it's it. But there's a problem. The Earth has an escape velocity of 11 kilometers per second. That means when they launch the rocket, leaving I'm sure now the rocket now is beyond the Earth, in between the Earth and the Moon. It has reached escape velocity of the Earth. So in other words, 30 kilometers per second, Earth's orbital velocity plus 11 kilometers per second. The speed of the rocket now is actually 41 kilometers per second. So the rocket must reduce its speed from 41 kilometers per second to 24 kilometers per second to match not only the speed, the direction and the speed of Mars, then only it can land on Mars. Otherwise, it's going to miss the target, right? That's it. And you know a bit about our, basically, everything is dominated by what? By gravity, So if you look at the whole system, the orbital, the calculation all depends. The main thing is called the sun. So basically, now it's just beyond the Earth. So the main dominant gravity acting on the rocket is the Earth's gravity. But I think when this rocket go beyond the moon a bit, just beyond the moon a bit, because the sun is more massive than the Earth. Although the sun is far away, but it's more massive. So just go beyond the moon's orbit. The gravity of the sun on the rocket is more than the gravity of the Earth on the rocket. So basically, most of the time, the rocket is traveling between the Earth and Mars. The gravity of the sun is dominant on the rocket. So actually, it's like this. You know what? When you take a stone and you throw on your hand on the Earth's surface, it goes up, you slow down, you go start and it fall down. It's the same thing here. So now, remember, I understand that the rocket, the first stage, will fire for about 8 minutes to go into space. And the second stage will fire another 12 minutes. So at the end of the 12 minutes, it will reach escape velocity. After it fire the second stage to insert the whole what they call probe towards the Mars, what happened to the rocket? The probe slowing down. You don't think that from the Earth in the space to Mars is firing for 7 months. Where got such a big rocket? Oh, too good. It's actually free energy going all the way quietly, free. It's just like this. You compare like that. Imagine there's a special case on the Earth. I'm driving from Butterworth to KL, and the roads are very, very, what you call, no friction on the road, all right, and no air resistance. So I start in Butterworth, I on the engine, I have a certain speed. After that, I shut down the engine of the car, and the car will just, with no friction, no friction between the car and the Earth surface, no friction between the car and the air atmosphere. So the car will just go free energy, slide like on ice, go to KL. But in the Earth, it's not possible because the Earth got what? Got friction between the tire and the road, and friction between the air. So from on a road vehicle, you must on the engine non-stop, traveling from Butterworth to KL. But for rocketry, different. After you fire, insert into the Martian transport orbit, cut off the engine. So it's actually flying, free falling, go quiet, free energy. So actually, it goes to the famous Homeland transport orbit, the famous orbit discovered by the Nazi scientists in the Second World War. So now it's actually on the way, the Tianwen-1 spaceship on the Homeland orbit between the Earth to Mars, such that if you follow the Homeland orbit, the amount of fuel required is minimum. And remember, like what I said earlier, when it was sent earlier into the low Earth orbit, so the Long March 5 can send up to 25 tons into low Earth orbit, And you know that each ton is like 1 proton dira. So on low Earth orbit, like in the ISS, the height of the ISS, the Long March 5 can send 25 proton dira. But to go to Mars, the whole lander, rover, and the orbiter is about 5 tons. But the maximum weight you can send the Long March 5 into other parts of the solar system is 6 tons. So the 5 tons is just below the limit. Anything more than 6 tons, the Long March 5 cannot send into Mars. But this is only 5 tons, so it can. So it's actually now on a Homeland orbit. So basically now is, once they cut off the engine of the second stage, as this spacecraft is going towards Mars, it's slowing down. But of course, it's faster. Now it's 41 kilometers per second. And hopefully, when it slow down already, it reach Mars, its speed will be what? 24 kilometers per second. You match the speed of Mars and the direction of travel of Mars, then it can enter into the Martian orbit. Not easy. And of course, we know that when you go for interplanetary travel, you need to have mid-course correction. That means, are you sure that when insert into Martian orbit, you travel for 7 months exactly? No. You will have some mid-course correction. So built into most of this rocket, they're called the accelerometer. Accelerometer means they measure the acceleration in the X, Y, Z direction. So basically, there are many types of accelerometer. The earlier type of accelerometer is the one called mechanical gyroscope, the spinning top. So imagine you have 3 spinning tops spinning in the 3 axes. You can measure the acceleration of rocket in 3 directions. And we know from our basic physics that if you integrate the acceleration once with respect to time, you know the velocity. Then you integrate the velocity, and then another time with respect to time, you get the distance travel. So knowing the velocity acceleration, you know the velocity accurately and the distance travel. Right. So, but nowadays they have. I don't know whether they applied in space exploration, but for many years they use this in research called electrostatic accelerometer. This accelerometer can measure acceleration XYZ to a nano G. Remember, Earth's gravitational acceleration is 9.8 meters per second square. Nano G means 1 billion of the G. So if they have this type of electrostatic accelerometer in Tianwen-1, it can measure the acceleration very accurately, tiny amount it can measure. So in other words, they know. So what happens is, on the way to Mars, and with the accelerometer, and sometimes I think in some spacecraft, they also have star finder. Inside the spacecraft, you have like telescope pointing at certain star. They use the star as a guide star. So if you look 3 stars at 3 different directions, 90 degrees with respect to each other, they will know how far the spacecraft is off the original trajectory. So either by accelerometer or looking at the star, they know, say after 3 months travel, they will know it's off. Then they have this called side thruster, small thruster in Tianwen-1 outside. You fire, let's say if you go to the left a bit, so you fire on the right, then the rocket go to the left. And also, pitch, yaw, and pull. All right. So all this, so be the side thruster, but side thruster is only to have slight change in slight force only. All right. So slight is, remember, the earlier you make the missed course correction, when you reach Mars, there's a big effect there. So early you make the missed course correction better. But of course, at the back of this Tianwen-1, there's a big rocket engine. That is what, and you reach the Mars, then you go to insert into orbit around Mars. Then you fire the rocket. And fire the rocket is not aiming going towards Mars. No, cannot. No, it's like this. I repeat. Now, it's now no more firing of rocket. It's actually going further away from the Earth, and the Earth's gravity is slowing down the Tianwen-1. And at the same time, beyond the orbit of the Moon, the gravity of the Sun is coming in. You can make the calculation. It's called our celestial mechanics, or the modern term is called astrodynamic. So beyond the orbit of the Moon, the Sun gravity come in. So the Sun gravity also slow down the Tianwen-1. So most of the time of travel is the Sun gravity slowing down the speed of this Tianwen-1. So when you reach Tianwen-1, maybe 1 month earlier, before reaching Mars, the gravity of Mars is there, but Mars is much closer to the Tianwen-1, much closer than our Earth or the Sun. Then Mars gravity will take over. So when it goes close to Mars, it's slowing down all the way to Mars. But when you go close to Mars, then the speed of Tianwen-1 will increase. Why? Because the Mars gravity is attracting it. So if like that, you slow down most of the time, near Mars will increase again. And when it increases it, hopefully it will match the orbital velocity of Mars, 24 kilometers per second. And of course, if the values are different, then you fire the main rocket. It's like this now. When you go towards Mars, don't fire the retro rocket to make it faster on Mars. You must what? You must brake, So that means they have to flip over the rocket such that the nozzle is pointing towards Mars to brake, to slow it down. Why? To slow it down so that it can be captured by the gravity of Mars to enter into orbit above Mars. Like this. So all these need a lot of calculation. And don't forget, even at the most, what they call closest distance, 55 million kilometers from the Earth, Mars opposition, it still take radio wave 4 minutes to leave Earth to go to Mars. And another 4 minutes to come back to the Earth. 8 minutes no delay to go and come, So that means the Chinese controller on the Earth, I think in a sense, the space rope to Mars is a bit of like robot. A lot of things can do. I think the main instruction that was sent from the Earth to go to Mars and come back to the Earth, minimum is still 8 minutes. But now, in February, when you reach the Mars, it's much further. I think maybe 20 minutes to go and come back. So it's not easy. Not easy. So the Chinese have their own radio tracking station in China and on the Yuan tracking ship in the ocean. And I think they also have a collaboration with the ESA, European Space Agency, Argentina, Austria, and so on, right? So a lot of things are involved in this. Yeah. Of course, the most interesting thing to
I
me.
think Dr. Chung elaborated a lot about that.
Yeah. To me, the most interesting thing is the actual mission when it opened the parachute. It will have this what they call burning the heat shield, enter into the Martian atmosphere, open the parachute, land on the parachute, and then later on, then the rover will roll down the ramp onto the surface of Mars. That will be most exciting. But we have to wait because you said that you enter into Martian orbit in February. But after that, like what I said, you orbit around Mars for another 2 months to study, take photograph of the Utopia Planitia, more information before they finally land. So the projected landing date is 23rd of April 2021. So we have to wait longer, more than half a year. Yeah.
So I think Dr. Chung gave a very detailed explanation on the trip of the spacecraft to the Mars. So if you are watching our live session, if you have any question, anything that you don't understand, feel free to comment in the live chat session. So our panels here will provide you a satisfied answer, most probably. So please feel free to comment. So I read about that in this Tianwen-1 mission is actually involve a lot of collaborations of a few countries, which involve like a few countries like what Dr. Chong say, Argentina, France, maybe Lai and Dr. Chong can elaborate a little bit on the collaborations on the spacecraft.
Yeah. Right? You can go ahead.
Just for information, actually, China they have one what we call they have one. It's like a radio station, something like that. It's like 一个那个信号的那个接收站。in Argentina, so that's why
Ground
they have.
station.
Yes, it's something like a simple ground station in Argentina. And if I still remember correctly, I read about it. This Argentina actually they provide this one of the payload, if I'm not mistaken, is on the magnetic field measurement, is it? Or it's from Argentina. And then they also have payloads from this ESA, which is the European Space Agency. So the whole mission is fully run by China, but some of the payload is actually collaboration from Europe, from Argentina, and from other countries. Yeah, maybe Dr. Chong can add on that.
So of course, we know that many types of space exploration projects are all what we call multinational projects, unless it is a military mission. So we know that Tianwen-1 is not a military mission. So China, for example, has opened its door. They like to have collaboration with all other countries, including the USA. It's only that the USA like boycott the China. So China and they have a lot of collaboration, and I'm sure this collaboration is continuous because you see, no single country in the world will have all the resources to explore the solar system. So the best is to pool your resources to explore. All right. So that means what? That means they'll sign a contract. That means the Chinese government will sign a contract with ESA. And remember, France is inside ESA, no? And France signed under ESA with China, and France signed with China a separate contract called France and China also. All right. So all this contract they signed is good for the future. Now coming to the actual mission, I don't know whether, because I tried to check, I couldn't find. You can try to go and collect the information for me. That is, I remember when the Chang'e landed on the moon, I remember they said that they showed that the Chang'e did a life science experiment on the moon. Remember? Is it they grow the silkworm live? Chang'e. They actually showed the video, no? That on the moon, Chang'e, is it Chang'e Sanhao? There's a kind of a silkworm, and it seems the silkworm actually become alive, From the egg, it became a caterpillar, A life science experiment. Of course, they also grow plants, types of plants. So now I was thinking whether when the Tianwen, the lander and the land on Mars, on the lander, of course, they will not do this life science on the rover. Rover is too small, 240 kilograms. But the lander is, I think, very heavy. So in the lander, will they do the life science experiment? They will grow the seed, put in some water, and see whether the seed will grow on Mars. And maybe they will see whether the silkworm can hatch, the caterpillar can hatch from the egg, and so on. So that'll be interesting, life science experiment. I think if they do this type of life science experiment, don't know whether this is permitted under the United Nations protocol. Remember, United Nations protocol is very strict, Mankind, when they explore the moon and the solar system, cannot pollute the moon and the solar system with our own organism, microorganism. Right? Because if you want to go and study Mars, see whether you got life, and then you bring life on Earth, you go and pollute it. Let's say out of the lander, one of the silkworm egg fell out down there, and let's say got water there, then it spread, and then 1,000 years later, you go to the moon, everywhere got mulberry trees. I cannot lah. So don't know whether it's allowed to do this type of experiment.
For this time, the mission, it does not carry life science
Yeah.
experiment. This time is more on geographical and composition
Yes.
investigation. Not sure whether in future there is such plan, but then the whole objective of planetary mission, interplanetary mission of China is very clear, which is they are actually looking for the origin of life. So include on why there's life in Earth, and also whether there are other intelligence living organisms in other planets or outside the solar system. So they actually have they're actually very well planned on this. All right. So currently for the first stage, since this is just beginning, the very first mission of interplanetary mission, so everything is still on the basic step. They go step by step lah. So for whether for the future they will have live experiment on these other planets or on moon, I have no comment on that, and I am not sure whether they will have that or not. But then, if for the space station, which will be launched, I think next year or in 2022, most likely they will have missions for that, life science missions for that in their space station. But then for interplanetary mission, I don't think there is for the time being, or any plan. Also, I have no news on that, so it is not, it's not appropriate to make comments on that for the time being.
So I agree with you. Like, very unlikely they'll do any life science on Mars experiment. Very unlikely. Yeah. So now the thing is, we know that the name Tianwen is by our Yuan, one of the China
Yes.
4th century BC famous poet.
Yes.
Don't know whether they are going to have a kind of his logo, his picture, and leave it on Mars, a plaque on Mars, so that in future, if people go back to Mars or aliens land on Mars, they will see the plaque of Yuan there. You never know. Yeah.
Actually, the logo is not related to Qian, but if you see the logo itself, it's actually is the Chinese planetary
I know.
exploration
I know.
logo.
Well,
So,
I mean, a separate plaque, with his name there, Yuan. Yeah. And maybe the Yuan, the logo, which hopefully they leave it there, is designed by a living present descendant of Yuan. Remember, in China, they are living descendants of Confucius, living descendant. So maybe the living descendant of Yuan. Okay, you design it, you sign it, you're going to send it and leave it on Mars. Oh, that would be great. Yeah. David, you can say anything? Very exciting, Mars, Mars, yeah. Of course.
But actually, personally, I have one question.
Yeah.
Yeah, I
Yeah,
read the paper published by the Chinese on Nature, and then they mentioned that the orbiter will be orbiting the Mars in a polar elliptical orbit. But I can understand that maybe for polar orbit they want to capture the whole Mars map. So, but then why elliptical orbit? Why polar elliptical orbit?
You see, okay, now I try to explain. To insert the Tianwen-1, the spacecraft into polar orbit is harder. You need more energy because the what you call the rotation axis of this Mars is more or less like Earth, more or less pointing towards Polaris. So now you want to enter into equatorial orbit, easy. That means you need extra fuel to enter into polar orbit. So you can. So in other words, they can do it into polar orbit. And the polar orbit, like you say, the Mars is the rotation period is a bit longer than the Earth, 24 plus hours. So in slightly more than 1 Earth day, Mars will rotate. So you're in a polar orbit, you don't have to go explore, not and stuff. Mars is rotating under the orbiter, so you can see the whole surface of Mars in 1 Martian day. The other one is why in the long elliptic orbit, one of the reasons I can explain is, you know that to study the magnetic field of any planet is very important. So sticking outside of the Tianwen-1, the long boom, they measure, it's called a magnetometer, magnetic field. So this magnetometer will poke out. Usually it's quite far away from the spacecraft, because if it's closer to the spacecraft got electronics, generate electric field, magnetic field. It can affect the magnetometer, so it's far away. Because if you want to explore, imagine you Earth's magnetosphere. An alien spacecraft want to map out the Earth's magnetosphere. It's always at the fixed height from the Earth's surface. It's a polar orbit fixed height. You only measure, let's say it's at 300 kilometers above. So you're only measuring the magnetic field at 300 kilometers of the Earth's surface all the time. Yeah, the Earth will take but only 300 kilometers. But let's say you have a long elliptical orbit. Perigee, 300 kilometers. Apogee, 3,000 kilometers. You can map the magnetic field from 300 kilometers above the Earth's surface to 3,000 kilometers. And at the same time, the Earth rotates. So that's why. So you want to see not only the magnetic field. Remember, they can measure the gravity very accurately. In other words, the strength of gravity of Mars. But you may say, I thought Mars is round. What? The gravity around Mars is the same. No. Remember when the Apollo mission, when they land to Mars, I went to the moon. On the Apollo mission, before landing on the moon, the early mission before going to the moon, they have this gravity meter. It measures the strength of the magnetic field. And without landing on the moon, but they fly above the moon, they find that certain parts of the moon, the concentration of mass is denser. So the gravity over there is stronger. Another part of the moon, gravity is weaker. That means the density of the rock is less. So by traveling in space around the planet, you can map out the gravity field. And they found that many parts of the moon have higher concentration. They call it the mass concentration. Similarly, you have a very low perigee. Perigee is for the Earth. For Mars is what? Peri-Mars, Apo-Mars. All right. So you have a very elliptical orbit. You can map out the gravity field of Mars. I think that is one of the reasons. Yeah. So I suggest
there's also one question by James Ong asking that, sir.
Yeah, I hear you, James. What is the question? Hong Zuan, you're frozen.
I think he might face some internet problem.
Yeah. You're hang already. Hong Zuan, you're hang.
I saw the question. The question basically is,
will China success? Oh yeah.
Yeah.
No, read again. Hong Zuan, your face is frozen, but your voice is not. Speak up again. Hong Zuan.
No, the question is like this, is because we know that from the 70s, I think we have a lot of missions to Mars, but then the success rate of Mars mission is about 40%. So that's why the question is, will this time will the Chinese success the mission will they success in this mission?
I can make a guess lah. I am very sure that in the highest authority in CNSA, they will not assume that it'll be fully successful. To me lah. Just to go to Mars and enter into orbit successfully is already a big achievement. First time, which the Indians did. First country do like India. The previous country, America, Russia, do not. They send to Mars a flyby only. America fly by Mars and went away, never come back to Mars. Same with the Russian. Later on, they send an orbiter. So the Indians at the first flight, they can orbit Mars, such a big achievement. So if the Chinese Tianwen mission can orbit Mars successfully, the other lander and rover not working, I think already is achievement. But to assume that 3-in-1 bonus, orbit Mars successfully, and remember, it's supposed to orbit Mars for 1 Martian year, no? 1 Martian year is nearly 700 Earth days, Orbit Mars for 1 Martian year, a lot of data, pictures and so on, and also land on the Mars, and on the lander a lot of experiment, and also got rover, also got a lot of experiment. All three, I think it's a very tall order. Too much to demand. But if let's say all three can work, the first thing is what?
World record.
Yeah. Well, because we know Yeah, Mars is a Martian graveyard for all. It's
And-
an American planet. Yeah, so I would think that for the American 美国, hey, we have another outsider coming kacau our rice bowl lah. Our rice bowl is Mars. America own Mars. Now another person coming in China kacau.
And just an add on a bit, in one of the interview I saw, the Chinese scientists, they seems to be very confident with their landing on Mars.
Yeah.
They are the more challenging part they think is actually after the transfer, whether the orbiter mission can be captured by the Mars gravity and go into the Mars orbit, which is the polar ecliptic orbit that Hong Zhuan mentioned just now. So that is after the transfer orbit, whether it can goes into the desired orbiting Mars orbit, whether they can that one is the one they think is more challenging compared to landing on Mars, and they seems quite confident if they could the orbiter mission is success, that means they can reach the desired orbit orbiting Mars, then they can perform the landing quite confidently.
Yeah.
Which they are expecting the landing will be success.
Yeah.
If they gone through the first critical stage, which is go into the orbit of the Mars. Yeah.
Well, if you do the so-called celestial mechanics of entering into the correct orbit of Mars, not easy, because it's coming towards Mars, not into orbit yet, it's traveling at a very fast speed. So remember, any slight mistake by 0.001 arcsecond, it will not land in the place in Mars 3 months later. So it must be very accurate to enter at the correct speed, at the correct angle. This is very accurate. But this is so-called enter the orbit means doesn't enter the Mars atmosphere. No. In February, it's not going to enter the Mars orbit. It's going to enter into space into the vacuum, into space around Mars. To enter, go around, and it's going to orbit around Mars for another 2 months. Then only in April, it will land through the atmosphere of Mars. So even insert into the correct Martian orbit is difficult. As I said, I think most likely they're going to fire the retro rocket. And remember, the retro rocket they fire for 3 minutes 33 seconds. It might be 3 minutes 33 seconds. 34 seconds more or 32 seconds, 1 second more or less, you will miss the landing spot by a lot. And yet the Chinese claim that they will land in Utopia Planitia with the landing ellipse of 100 kilometers by 40 kilometers. They always quote the landing ellipse. That means, remember, when you land on an object, the error in the length should be more than the error in the width. So the length is 100 kilometers. The width is 40 kilometers. So within this ellipse on Utopia Planitia is where it is supposed to land. So that means when they enter into the Mars orbit for 2 months, you orbit Mars, you take a lot of pictures, maybe they will make a final decision on which exact spot of Utopia Planitia to land with the latest information of their orbiter, a photograph of Mars. Yeah. So if you look at the landing ellipse, I think it's similar to what the Americans have done with Curiosity and Spirit Opportunity. So that means the Chinese rocket technology is quite accurate. Landing ellipse of 100 kilometers long and 40 kilometers wide. Yeah. David, say something.
Comparing to the space technology like 50 to 60 years ago, I think the advantages for India and China today is the improved technology. For example, the computer technology. I mean, the computer technology nowadays is uncomparable to 50 and 60 years ago, I think.
Yeah, I fully agree with Hong Zhuan. I add more. Do you know what? With this Mars mission, thousands and thousands of young Chinese kindergarten students, primary school students, secondary school students, university, 我要去火星, I want to design the Mars rocket. They all be attracted into space exploration. It will bring up a huge generation of the Chinese students to do space exploration and also astronomy. Sure one. And I'm sure, remember, each time they collect the land on Mars, for example, Spirit, Opportunity, and Curiosity, you know how many PhD got their degree in America from the data of this rover and the lander? A lot. So that means many of the young Chinese space scientists in China, wow, they're pressing their head. I hope successful. Then they get a PhD lah. So maybe from the data of the rover right now, what's the name of the rover? Not decided yet. No, why so late? Still not decided. No, the rover, the orbiter
Like
at Tianwen. Yeah, they are supposed to give the name of the rover. The American one, remember? American one was one young American girl. He's actually a Indian origin but American student. She gave the word perseverance. No. Perseverance. No. Perseverance. No. She gave the word ingenuity to the Martian helicopter, the NASA one. And they featured her on the YouTube, so the ingenuity was just announced only recently. The Martian helicopter, the American going to release from the Perseverance rover on Mars. But the rover, the Chinese rover on Mars, still no name. They should give a name. Yeah. So I'm sure, as I say, Papa, Mama, 我要去火星，我要做这个，I'm sure a lot. I'm sure. Yeah. So I'm
So
sure.
maybe. Yeah.
So like when you go back to Beihang, I'm
Yes,
sure.
Doctor, you can continue.
I'm sure some of the professors in Beihang will start more research of either on the space technology to go to Mars or the scientific experiment data on Mars. They can analyze. Yeah.
Maybe I can explain a little bit about them and all those things, because the information is actually not much. I read that they mentioned that there are 6. Oh, no. I mean like maybe you can elaborate a little bit about the rover technology, because from internet, for me, I only managed to search about the basic instruments on the rover. So they mentioned 6 instruments, and then they did mention about the robotic arm technology. So maybe you can elaborate about the sample collections of the rovers and how it is done compared to the American rover, for example, the latest Perseverance or maybe Curiosity.
Okay. I show some photos and then we discuss a bit photos by photos. First is on the landing spots.
Yeah, that was great.
Wait, am I presenting?
Yeah, I don't see. I see
you don't see it.
I hear you, but I don't see your picture, your note. Present.
Yeah, we can see your.
Yes. Okay, now see your present. Wow, nice.
Okay.
Okay, so you see there are 2 parts actually. I draw the point. Okay, so this is the 2 expected landing spot of the Tianwen lander. So one is near the Viking and the other one near inside. So which will be the final landing spot will depends on the results from the orbital mission.
Yeah.
So next is this. Next photo. Let's see next photo. So this is the. Oops.
Now you allow me to say a few words.
Yes.
According to the information, the Chinese Mars orbiter, if you can insert into Mars orbit successfully, the resolution of the camera in the Chinese orbiter is as good as the American Mars Reconnaissance Orbiter, MRO. Remember, still in orbit of Mars is the NASA orbiter called Mars Reconnaissance Orbiter, very high resolution. So this Chinese orbiter is the same resolution. So you can take this high resolution picture of the potential landing site on Mars. It will help the Chinese a lot. Yeah.
Yes. And this is about the payload on the payload of the Tianwen orbiter mission. So this is the orbiter module. Can see over here we have the solar panel, all right, which provide power supply, and then this small thing over here.
I don't see. I see the map of Mars only. I don't see the.
Yeah.
I don't see the map.
Yeah.
Put the orbiter in. I didn't see the picture of Mars.
Is it? I thought I changed.
No.
Wait.
No. Just now is the map of Mars only.
This one.
No, I want the orbiter. The picture of the orbiter.
Yeah, it's coming. Yeah.
You see, Okay. So this is the solar panel for the power system. And then we have the small probes over here is to study the Mars subsurface. All right. And then we have radar. And then the high resolution camera is over here. High resolution camera. And then another medium resolution camera is over here. And then, of course, we have a big antenna which will be pointing towards Earth for communication purpose. And another antenna is a low frequency antenna over here. So this big dish is the antenna, and there's also another low frequency antenna for communication purpose. And also we have mass ions and neutral particle analyzer is to study the atmosphere of the Mars. And another small thing over here is a small probes over here is the Mars energetic particles analyzer. And also they also plan to study whether there are minerals on Mars, right? Whether there are valuable minerals like gold, silver, such minerals on Mars, especially those rare elements in the periodic table. If there is in Mars, and that's why they are studying on that. So they have this mineral spectrometer. So just in case if they found any valuables, rare elements in Mars, and then they will be very happy on that. And just to add on, for this time, we don't have
mining.
This mission don't have this sample return. But the next mission, which is Tianwen-2, that they will plan to have this sample return mission. So just a little bit add on how they carry out the mineral composition analysis is after they land the rover, so they use the laser technology because we know laser is very high power. So they will heat up the sample. So it will pick a little bit of sample, the soil sample, and it will heat up. And then based on the emission, they will study what are the components inside. So 简单的说就是用一个烧死的情况，烧了之后用高温use high temperature to heat up the soil and then to study, to analyze the energy emission.
Kind of like vaporize.
Yes, something like that. Yeah, so this is on the mission. And the next one is I would like to show is this is the rover. All right. So this is rover. Can see, Yeah, this is the rover. I'm sorry, but I could only find the pictures in Chinese. So there are 3 cameras. All right, there are 3 cameras on the rover. All right, and then the 6 wheels is actually independent. All right, so it's independent, which is different from our car. Our car, the 4 wheels are related. So if one wheels go into the longkang, then the other will have problems. But this, the Mars one is a bit different because 6 of this is independent. So let's say if something wrong with one of the wheel, the other 5 still functioning. So it just to make sure that the movement on the Mars is like a protective measurements for the motion for the rovers to work on Mars. And then it's powered by solar system, so there are solar panels on the surface. All right, and then they have this meteorological probe, which is to study the pressure and the temperature on the Mars. All right, study that the air condition, which is the temperature and the pressure. So there are pressure sensor and temperature sensor, and also this thing over here, this part. All right, this part is to study the composition of the soil of the Mars, and then beneath this main body, okay, under this yellow box on the side, and under this they have the sub-layer radar. That means to study what is going on below the surface of the Mars. All right, below the surface of the Mars, of the surface of the Mars. And also up here, okay, just right below the camera, they have also for meteorological purpose, okay, this is to study the wind, all right, the wind of the on the Mars, study the wind, 风场声音探测探头, study the wind, because we know that Mars often they have sandstorm, so they want to study on the wind on Mars. All right, so this is basically about the rover, the Mars rover. All right, the Mars rover, and just now the Mars orbiter. So
what about the Mars lander? The experiments on the Mars lander?
The Mars lander is actually after landing, then they will release this.
I know, but there are also some experiments built into the Mars lander. So
I don't have the photo of the Mars lander, unfortunately.
So I understand like this. The Mars orbiter got experiment. The Mars lander also got experiment. The Mars rover also got experiment. So three of these.
From the paper they publish, they only mention there are experiments on the orbiter and the rover only. They didn't mention anything about the yes.
Because
as far as I understand, is the lander main purpose is to land and then release the rover. Yeah, that's why they are pretty confident with the lander, because the function is pretty simple, and they have performed couple of tests on it on simulating the environment of Mars and then simulate the landing condition, and they are quite confident on that. So I think it's quite simple for the lander itself, but then the main character, the Wata Utama, is still this rover that will be working the most lah, and it will work for 90 Martian days.
I actually wonder how they actually simulate the landing.
Simulate the landing. Actually, I have a video, but I'm not sure whether I can show or not.
The 7 minutes of terror.
Not the 7 minutes of terror yet, but then it's just to make sure that the what you call the lander can land softly, so that when it lands, the rover don't damage. So that is on the landing test. It's actually I described a bit lah, but because I'm not sure I can show the thing or not. It's like when because the gravity of Mars is lesser than Earth, so when you want to simulate it on Earth is a bit difficult. So one of the way is they actually hang some ropes and generate some lift force for the lander, so it simulates like the weight of the lander is about the same with the condition when landing in Mars lah.
So allow me to add on, So I remember I saw a few months ago, the Chinese invited many of the journalists around the world to go to China to show how the Chinese tested this landing process. So the huge power they build it, and they actually carry it with a cable, the whole lander, and the rover on it, and then they show it how it dropped, not to say drop lah, go down very fast and landed in front of the foreign reporters. They did it. I think
you can find the video.
Yeah, that's it.
You all can find the video online. I'm not sure whether you all could see it, but then you can. I think you can get the video online. That is one of the landing tests lah.
So maybe you can go back
from the description. Yes, doctor, please.
You can go back to the orbiter. I'll just add on some information. Okay.
You want to have a look on the orbiter? 1 minute,
Yeah, orbiter. Just now you showed us the orbiter. I have some question. No, usually, any type of spacecraft, their solar cell is like a two long wings sticking out, isn't it? But this orbiter, the solar cell is at the side of the spacecraft, very small only. I thought it's two wings sticking out, two
No,
long.
this is the
I
stow
think the
configuration.
European Rosalind
Oh,
is
no,
also the
this
same.
is the no. This is the stored configuration, not yet open out. Not yet open
This
out.
is the stow configuration. That means this together with the lander, it will be put like this so that they can fit in the rocket.
No,
But
I
if
know, I
they
know. That means
extend the thing out,
because I saw just now one video already entered insert into Martian orbit, just left the Earth. Already the two solar panel like a bird's wing sticking out very far out already stuck out.
yes.
But
yes.
this is before opening the solar cell, before opening.
Yes, this
So in
is
other words,
we call it the stow configuration.
so that means each let's say on the right side you open up a length maybe a few times wider than the orbiter itself, and the left also orbit. Now the other one, of course, we have to be very careful because Lai mentioned just now that it has a mineral spectrometer in orbit around Mars to study the minerals. So some people say, how? You have to go down to the Mars surface, land on Mars to dig out the soil to study the mineral? No one. Why is it in space you cannot? The answer is yes, you can. In space you can. How? You look at the light scattered off from the Martian surface, and you have a spectrometer in the orbiter. A spectrometer basically looking at Mars at various wavelengths, either in the visible wavelength or infrared or UV. So by studying the light scattered off from the surface of Mars, but detected in space at different colors, you can know what type of minerals on Mars. That's what they do. Okay. Then on the lander itself and on the rover itself, there's also experiment to study the minerals. That is in situ experiment. That is on site, on the surface of Mars. You can actually go close to the materials on Mars and you can study them, the minerals. So there are two ways. And just now, I also mentioned that the orbiter also got radar, you say what? Radar, isn't it?
Yes.
For example, the rover also got subsurface radar. No, subsurface X-ray. Subsurface, to study the subsurface.
Exploration radar.
Radar. So now, the orbiter has a radar. You beam towards the surface of Mars from space. You beam few hundred kilometers down the surface of Mars, and from the scattered back information, you know what is underneath the surface of Mars. And at the same time, the rover on Mars also got another this type of radar would beam information down onto the Martian surface and can detect. I remember the Chang'e one, they have a similar type, and it seems Chang'e can study 100 meters below the surface of the moon. 100 meters, no? Very deep, very deep. The Americans don't have this technology so far. So if it's the same, that means this Martian rover, the Chinese rover, can beam the radio waves up 100 meters below the surface of Mars, and the information scattered back, they can know the rock layer structure, mineral, 100 meters below the surface. So that's what it is. So now I just want to ask a question for the people who are listening now. I give you 1 minute. So I'll ask a question. 1 minute, I answer. Why do you use solar cell on Mars? Orbit around Mars, orbiter got solar cell. The rover also got solar cell. Why do you use solar cell? Some people say, how can? Of course, must use solar cell. The answer is not necessarily solar cell. If you are to land a lander on Io, the moon of Jupiter that has volcano, you cannot use solar cell. Of course, you may say, because Io got volcano, the solar cell is destroyed by the volcano. No. Even if Io don't have volcanic activity, you cannot use solar cell. Why you cannot use solar cell when you are the distance of Jupiter from the sun? But on Mars, on Earth, on Venus, on Mercury can. Why? Why Jupiter, Saturn, Uranus, Neptune, Pluto cannot? Why? Well, I give an answer. It's a strong hint. You look at if you are now standing on Mars, you look at the sun. Of course, the sun is much smaller than you look at the sun from the Earth. But on Mars, you look at the sun is still very bright. It's a smaller dot, but still very bright. So you can still feel the heat of the Mars sunlight on the Mars. But you're not in Jupiter. The sun is just like a bright star in the night sky. Around the sun is all dark. On Jupiter, you look at the sun, around the sun is all dark. Only where the sun is a bright spot, like a bright star. So the sun's light at the distance of Jupiter is not enough to energize the solar cell, to generate electricity for the spacecraft or the rover. So that's why further away, then as far as Jupiter and beyond, cannot use solar cell. So what do they do? If you want to send a space probe there, cannot. They use radioactivity. So you have a radioactive source there, and you generate heat in the radioactive is a mini nuclear reactor, and when it generates heat, is what? It's our thermoelectric effect. So you have a hot junction inside where you have the nuclear, the radioactive material, and the cold junction sticking to space. So between the hot and cold junction, it generates electricity. And the radioactive heat can be generated for thousands of years. So further away than Jupiter, you need radioactivity. Just like the Pioneer 10, Pioneer 11, Voyager 1 and 2 flew away upon the solar system. What is the source inside? Not solar cell, because you look at the sun is just a bright star. Radioactivity. Yeah. Any more question, Hong Swan, from the watchers, listener?
Actually, from the explanation just now, is that mean that the landing, I mean the lander or the landing procedure is different from the sky crane of the US NASA? Because like for the sky crane is something like hanging, and then the retro rocket is attached. Is on top of the rover, and then with some strings attached to the rover before slowly landed the rover lah. So is that means that like for the Tianwen-1, the rover landing procedure is different from that?
Yeah, I can answer.
Is that the retro engine is at the bottom of the lander?
Yeah.
I mean the platform.
Yeah. So I can answer the main part lah. The detail I don't know. The Perseverance is more than 1 ton. Heavier than the car. The Tianwen rover is about 1/4 of a ton, 4 times smaller. So definitely the technology will be simpler for Tianwen-1. So they will not use sky crane for Tianwen-1 rover, right? Because it is actually much lighter lah, right? But I saw when they demonstrated with the foreign journalists is that there were long cable lander, and on the lander is a rover. They just drop it, and I see a lot of websites. The Chinese will say that they will use the what you call the orbiter when they enter into the Earth. The lander when they enter into the Earth, into the Mars atmosphere, there has a heat shield that will be very hot for 7 minutes, right? And then later on, enter into the denser part of the Martian atmosphere, the heat shield will drop off, and the back shield, the top part also will drop off, and then the drogue chute will come out, and the main chute will come out, and they will have the parachute to block it. And then they also mentioned that at the last moment landing, retro rockets and airbag. I saw the word airbag. That means if they say airbag, that means it will be the Spirit and Opportunity technology. Because Spirit and Opportunity is about the size of this, what you call this, Tianwen rover. Because Perseverance is 4 times heavier, no? The technology is different. So Perseverance one, it's accuracy, very difficult, no? Like you said, the sky crane, no, not easy. So if you look about it, for the full mission to succeed is what? Orbiter must work, lander must land successfully, rover must deploy. Right from the launching from Wenchang to land successfully and to have the rover moving around the surface of Mars. You know how many dangerous processes? Anyone can go wrong. The whole mission is out. No. So to me, if the orbiter can enter the Martian orbit successfully, the other part not successful, it's a big achievement. Yeah, this is the one.
So I just show
the video.
Something.
So the big thing on top is not the lander, it's the one hanging below. That is the lander. The big thing on top is just a kind of fixture to hold it only. And this tower is very tall, no? Very tall. All right.
Yes, the one with the smoke coming out from the bottom. This is actually the what do you call retrograde rocket?
Yeah,
is it?
Yeah.
We call it in Chinese. We call it 反推测试. That means it goes against the so-called against the propulsion from the direct translation. That means against the propulsion of the original rocket direction.
So very high.
So this is
a very tall structure, many stories high. Yeah.
yes. This one you can find online, so I can just simply show you this.
So at the ground level, there are hundreds of reporters around the world watching. Hundreds of reporters. Yeah. Can you play the
so
video? You have a video? No video, huh?
No, not a video. This one is a photo.
Picture, okay. Yeah.
A picture. So I can show you the picture. I don't have the video also. And I remember just now Dr. Chong did mention about the 7 minutes of terror. So maybe we discuss a bit on.
That's the most exciting part.
Yeah. This 7 minutes of terror. There are two things that maybe we should think of this first lah. First is we call it 7 minutes of terror because the whole landing process of the lander on Mars surface from the orbit to Mars surface, it takes 7 minutes. So we call it 7 minutes of terror. So basically the whole landing process is a very terrifying thing, terrifying event. So the whole 7 minutes is known as the 7 minutes of terror. So the first thing is maybe you all can think about this is the communication time, the signal delay from Mars. So that means from Mars you send a signal. So until it reaches the Earth, how long it takes? It actually takes the fastest. It takes I remember it's around 12 minutes. So the landing time is 7 minutes, but the communication time, the signal delays 12 minutes. So let's say the Mars lander send a signal back to Earth. So it takes 12 minutes to reach the Earth.
Yeah.
So before the signal reached the Earth, it already landed on the surface. So this is one point. And this 12 minutes does not include the signal we give to the lander. That means if the lander gives us a signal and we reply to the signal, it will requires about, the fastest will be 24 minutes. So by that time, the lander already successfully landed on the Martian surface. So this is basically the whole landing process should be artificial intelligence. That means the lander itself must be intelligent to cope with all the possible risks that might face during the landing. So this is the 7 minutes of terror. This is the very basic explanation. But actually, if we go into more technical and more details about this 7 minutes of terror, it's actually what we call a communication blackout, or we call it a blackout zone. So in human flying history, we actually have 3 barriers to overcome. The first one is the sound barrier, which is we have to break through the speed of sound, which we successfully solved that with a turbofan jet engine with an afterburner. We managed to break through the sound barrier. So the sound barrier, we have successfully settled that. So solved that, not a big issue. The second and the third barrier is up to now, many researchers are carried out to solve these 2 barriers. One is the heat barrier. Heat barrier, remember when we re-entry to Earth, every manned mission, when we go to the space, especially like even the recent one, recently a very hot topic, the SpaceX Crew Dragon, when they want to come back to Earth, they will experience this, which is the second barrier, which is the heat barrier, which is when they re-entry, the Mach number is very high. It's a hypersonic speed, hypersonic traveling. So the Mach number can go up to 30, 40, okay, 20 to 40. So usually around 30. So that means 30 times speed of sound. So the friction is very big, and then a lot of heat is generated. So the surface temperature of the capsule can go up to 2000 degrees Celsius. So which is very hot. And to solve this issue, the only one of the way is we have to make sure that our structure can survive under this heat barrier. All right. So to survive under this heat barrier, one of the method is we apply a layer of graphene on the surface. So at high temperature, it will sublimate, and when it sublimate, it will bring away the heat.
Yes.
This is one of the method. And also, of course, there are insulation technology, and many things are still improving through these years of research, and the material is getting better and better. So I remember in previous discussion session, Hong Juan did ask me about what is the difference of there's a test module on the new Chinaman spacecraft, is the outer layer of I forgot the name already, but it can be removed and then change. So the outer layer, they can change. So the inner layer they can still use. So this is currently the method or the ways, the technology we deal with this heat barrier. And that is not the most critical and the most dangerous one yet. The most dangerous one is the third one. We call it the communication blackout. So for Earth re-entry, we will have this communication blackout. It's basically at high speed because of the heat. So there's a layer of plasma and ion around, it's like covering the whole capsule, causing it that the communication signal cannot penetrate through. So having the whole capsule is isolated from all the signals. So usually for Earth re-entry, it takes about 10 minutes. And for Mars, this phenomena also happens not only in Earth re-entry. So in Mars re-entries, they also have this. Okay, I read through some articles, and it says that this actually happens since the first missions, the Viking, is it, in Mars? When it lands on Mars, because at the beginning of the landing, the velocity is very fast. So they experience 30 seconds of communication blackout. And this communication blackout, we can't escape from it yet. We don't have any technology to solve it. We did try using more powerful antennas or whatever, but then this is still not solved yet. So this is a very dangerous, period of time. So for Mars unmanned mission, something happens, it still did not harm the life or whatsoever. But then if this happens on this human mission, so that few minutes, that 10 minutes of blackout period is actually, we usually say is actually depends on your fate lah. See what happens during that 10 minutes. So this is about a bit technical knowledge on the blackout area lah. So a simple way in Chinese is say, 飞行我们有三障，第一个就是阴障，第二个就是热障，第三个就是黑障啊。And then the 阴障 or 声障, we already break through the sound barrier, the sonic boom. So if we break through the sonic boom, basically that means we break through the sound barrier. So the heat barrier and the blackout zone is still a very hot topic in research, in aerospace research.
I just add on to what I said. So if you want to compare a spacecraft re-entry and land on the Earth's surface, through the Earth's atmosphere, land on the Earth's surface, or another spacecraft enter the Martian atmosphere and land on Martian atmosphere, you have to take care of two factors that are different. First of all, Earth's gravity is stronger than Mars. All right. The Martian gravity is on the surface is 37% that of the Earth. It's like 1/3 the gravity of the Earth. And the Earth's escape velocity is 11 kilometers per second. Mars escape velocity is 5 kilometers per second. That's the first difference. The gravity is different. Second thing is the Earth atmosphere is very thick, very dense. Martian atmosphere is very thin, 100 times. So in other words, you don't expect when you enter a space probe into the Martian atmosphere, it will behave exactly like Earth's atmosphere. Different. Because here, the atmosphere of Mars is very thin, but the gravity is bigger. So in other words, the character is different. So that means, assuming that the gravity of Mars and the Earth are the same, So for the spacecraft to be slowed down by the Earth's atmosphere, it needs a shorter time. But of course, the G forces are great lah. But to enter into the Martian atmosphere, you need a longer time for the Martian atmosphere because it's very thin in Mars. You need a longer time for the Martian atmosphere to slow down the spacecraft. So you have to take into account this. All right. Now the other one is, remember, the lander and rover will not get the information by exploring the surface of Mars and directly beam the radio directly back to Earth. No, it will beam from the surface of Mars to the orbiter orbiting around Mars. So the orbiter will be a relay from the surface to the orbiter, and orbiter sent back to the Earth. That is what it do. So the orbiter must work. If the orbiter communication system is not working, susah. The rover lander is getting a lot of data, and they send it to the orbiter. It can get the data, orbiter, but the orbiter antenna pointing at the Earth is not working. Susah. So orbiter, all the communication in orbiter must work. So everything must work. Not easy.
Yes, yes. So it doesn't mean that the orbital, after it release the lander, the mission ends. No, it's actually the communicating relay is the bridge between Earth and the rover. So that is very important as well.
It is not just the orbiter must work, Suppose now, the rover now is getting a lot of data lah. But the orbiter is on the other side of Mars, on the other side, blocked by the surface of Mars. So the orbiter come into the view, overhead the rover, and only the rover can send the signal to the thing. All right? So remember, the low Earth orbit around the Earth is 90 minutes. I don't know for Mars, low Earth orbit is how many minutes. I don't know, because weaker gravity, maybe it'll take a longer time orbit. Say, one orbit around Mars is 2 hours lah. So for 1 hour, the orbiter cannot be seen. Second hour only can. So it doesn't mean that it can transmit from the rover to the orbiter 24 hours cannot. Only when orbiter is in the sky only you can transmit. So not easy. Now another thing is, like you showed just now, the orbiter, very interesting. The antenna beam back to the Earth. Can you show the picture? I test you all. Show back the orbiter. I asked this question many times. So I don't have the full confirmation, but I think what I educated guess, most likely is correct. Show the orbiter. Show the antenna of the orbiter transmit the information back to the Earth. Now everyone see on the right side, there are two parts of the orbiter. The one on the right, you see a big antenna pointing to the left, isn't it? So that one will beam back the radio signal back to the Earth. The question is this, if they bring it back to Earth, why not in Malaysia I build a big radio receiver and detect the signal from the Tianwen orbiter back to the Earth? I receive it, so I also get the same data as a Chinese scientist, isn't it? Or the Russian got a big radio dish in Russia. They can detect it. Why not? We can. The information, you mean to say they beam back the radio information, we pinpoint it will go to the radio antenna in Xinjiang, West China, exactly. No, it will be very broad beam. The beam that is sent by that transmitter will cover the whole Earth many times. So if anywhere in the Earth you have a radio receiver, you can receive it. But the actual fact is you cannot get information. So I'm very sure the information they sent back to Earth is coded. 1,000 bit encryption. Very highly encrypted one. You must have the key to be able to decipher it. Must be one. Yeah. Otherwise, the whole world can get it. Like the American probe, the Russian probe, they sent back to the Earth. But why only those countries receive? You mean to say Russian spacecraft sent back to the Earth, American got it, but American don't tell people. No. After so many years, 50 years of space exploration, we never say that it's a Russian mission. American also got information. It's all coded one. What do you code it? Not easy.
So I think now the time is not early. We have been conducting the session for like more than 1.5 hours, I think. So I think maybe it's almost the time for us to end. So maybe before we end it,
I want to share something more interesting yet.
Okay, so in the meantime, if you have any question, please post it as soon as possible. So now I will let our Mr. Lai to talk a little bit.
we talk a lot on the lander, but we actually neglect a bit on the rocket. Just
the rocket.
some simple facts on the rocket. Now, in aerodynamics, we always want smooth surface so that the drag is lesser. But did you all realize something is, you see on the rocket, this surface is not smooth, you know?
Why I always ask myself the question like,
I'm not sure you all think about this before, but then this is something, just something for you to think about it. Because this Long March 5 rocket, they have a lot of nicknames, you know. They even call it a green rocket. Why? Because it's clean, right? They use liquefied oxygen and liquefied hydrogen. So the problem is this, or maybe you all can think, I give you a little bit of time to think, what are the possible problems that they might face in this rocket, all right, using liquefied oxygen and liquefied hydrogen as the fuel of the rocket. It's basically like this. Liquefied oxygen, the temperature for oxygen to remain in liquid state, we need about negative 180 degrees Celsius.
wow.
For hydrogen, we need even lower temperature, negative 250 degrees Celsius.
Wow.
So it's very, very close to absolute zero already. So in this rocket itself, over here is the oxygen tank. And then this part, okay, this part is actually the staging part. So this is the oxygen tank of the first stage. This is the hydrogen storage tank for the second stage. So at this staging part, it's not smooth. We don't have a smooth surface. So to understand this, we have to understand the problem first. So what is the problem? The problem is basically like this. Imagine you have a cup of ice water. You just leave the ice water on the table. So what happened on the surface of the glass after a short while is you see water droplets on the surface, right? So the same thing goes to the rocket. Inside is the fuel tank. So the temperature is very low. And then outside is the atmospheric temperature. And now it's summer season. So the temperature in Hainan might go up to 30 something degrees Celsius. So it's hot. And Hainan is the southern part of China. Unlike in Beijing, Beijing is very dry, but in Hainan it's very humid. So that means there are a lot of water vapor in the air. So the same things will happen. So on the surface of the rocket, it will start to have water collected on the surface. And because of the temperature is very low, so on the surface of the rocket, after a short while, icing will happen. So that means ice will be on the surface. So remember that the first stage and the second stage is separated. So that means there are very small gap between. So if this water goes into the gap, then after this water frozen into ice, and we know ice, it has some adhesive force. So it's very dangerous if icing happen, if icing happen on the 2 stage, and then when it is launched, ice is present in the gap. The adhesive force might cause problem for the first stage to be detached from the rocket. So it's very dangerous. So that's why they have this rough surface. Actually, it's like in Chinese we call it 挡水条. That means, in certain bathroom design, they have a small tiny tiles to block the water so that the water don't flow everywhere. So this is to prevent the water from the top part of the rocket after it coagulate on the top surface, and when it drips down, it don't goes into the gap to cause freezing, to cause ice present in the gap. So that's why the surface over here is not fully smooth. So this is one of the reasons. So over here, there's actually slightly there's something like a thin plate to block the water from the top surface. So this is it. And then in the fueling part, when before the launch, actually there are also stages when they want to fuel the rocket. Is I think I have the photo, but I don't have. So this is the image of the full rocket. So this is the fuel tank, right? The boosters, the fuel tank. So actually, in fueling the rocket, that means refueling the rocket, there are 4 stages. The first stages is they start with a very slow flow rate. They start with very slow flow rate. The intention is not to fill the full tank. It's actually to cool down the tank, cool down the liquid tank, because outside the temperature is high, but then liquefied oxygen, liquefied nitrogen, the temperature is very low. So if you directly low temperature pump inside to the fuel tank, the temperature difference will cause deformation on the fuel tank, and then the whole rocket, the fuel tank will deform and destroy. So the first stage is they will slowly let in a bit by bit of the liquefied oxygen, liquefied nitrogen to first cool down the tank so that the temperature slowly decrease. The temperature of the fuel tank slowly decrease. So after it decrease to about the fuel temperature, then only they start the main stage of fueling. That means they will pump in the liquefied oxygen and hydrogen very fast. And after it reaches a certain level, before it launch, you still see there are like white smoke coming out from the rocket. That one is actually fueling still continues until a few seconds, a few minutes before the actual launch. Why? Because the temperature outside is very high, and this fuel is gas, it's oxygen and hydrogen. So they will leak. They will evaporate and leak. So they will leak out from some small gaps or tiny holes on the rocket body itself. So that's why they have to be continuous filling until a few minutes before the icing. Before the launch, only they will stop the refueling process lah. And just a little bit add on on the icing just now is even in winter time you have the icing process for aircraft before it take off. So for rocket we cannot do the de-icing part. So that's why we need these precaution measurements on the rocket design itself to prevent the effect of icing. So there's a little bit additional information for this lah, for the rocket itself lah.
I just add on to what Lai has said, and then I'll give my extra comment. So basically, some people will say, so much problem with liquid oxygen, liquid nitrogen, but why use liquid oxygen, nitrogen? Why not change the different fuel? The answer is this. Liquid oxygen, liquid hydrogen fuel has a very high specific impulse. The thrust is very great. That's why they use liquid oxygen, liquid hydrogen. Just like for the space shuttle, remember the big external tank? Liquid oxygen, liquid hydrogen. Because of the very high specific impulse, the thrust is great. They have no choice. So there's the advantage, high specific impulse, but disadvantage is very cold.
And clean.
Yeah, because then you may say, why don't they use the fuel that they send the Shenzhou from Jiuquan in the Gobi Desert? They bring to Hainan. Cannot. The Shenzhou is UDMH, unsymmetrical dimethyl hydrazine, plus N2O4, dinitrogen tetroxide, toxic. Do you ever see the Shenzhou launch from the Gobi Desert? Brown chocolate color fumes coming out. The Shenzhou, Long March 5 is white smoke. Basically, like you say, liquid hydrogen, liquid oxygen you burn is water. Just like you burn hydrogen gas with oxygen gas. Provided it's safe, it's pure water. So water comes out. That's why Long March 5 is green technology, safe technology. They cannot launch the Shenzhou rocket fuel in Wenchang, no? Then all the 1,000 people on the beach will be poisoned, So that's why they cannot use it. So they have to use this thing. So they can. So because the main reason because it's high specific impulse, but the disadvantage is cold. Now just add on some comments. Now just now Lai mentioned that in the orbiter and in the rover, they're altogether about 12 experiments. You will follow the previous many of the NASA mission to the outer solar system. You know that each single experiment on the spacecraft, on the ground, in the Princeton University, there's a professor leading that group for that experiment. And that professor for that experiment may have 5 or 6 PhD students. So similarly now, in the orbiter and in the lander, the Tianwen, you have 12 experiments. Each of the 12 experiments will be headed by one group. So there are 12 groups. And each group will be, in NASA, they call the principal investigator with his group of researchers. So say you have 12 experiments, I mean, there are 12 groups headed by one principal investigator. And usually the principal investigator must be a researcher or a professor. So that means, and who are the other people? The researcher, the PhD student, so not easy, So I'm very sure some of the young Chinese students who are interested to do space exploration, in our university, there's professor on that subsurface radar on the Tianwen rover. So they want to go and talk to him. Can I join your group next year? So this, so 12 groups with 12 principal investigators with many researchers, many PhD students. Yeah. So Malaysians, you are keen to do what I call this space exploration. You think about it, go to China, like our life. Yeah. Any
So
comment by
Junsen, do
David?
you have anything to add on?
I don't think so.
Or maybe a question for
So
you
maybe
is
we
you are,
can
you are
call
the
it.
younger generation. So what is your expectation on the future aerospace development or the space technology development of the country?
Of the world or just China specifically?
I mean for Malaysia, or it depends on how you want to see it, for Malaysia, for China, or for all around the world. It depends on what are the answer you are giving. It's a very open-ended.
I'd be very honest lah, From the support of the government, I don't think Malaysia is going to have a good a rocket faring country lah. Most likely we'll just send astronaut to either Russia or US or China to send them up to the station. But I don't think we are going to have rockets anytime soon if the government shows the same amount of support they are today lah.
So just more detail on the young people pursuing a career in space actual research. So don't get the idea, you young people out there in Malaysia or around the world, think that I must be interested in rocketry. I must be a physics student. Then only I can take part in space. No, you can be a biologist. Life science is very important in space exploration. I can be a chemist. All right, I can be an X-ray. I can be a computer programmer. You can be in any interest. There is a field you can do research in space exploration. It's open to everyone, actually. Yes. That's all I have to say.
So I think, yeah, I think the time is about right. So now it's 10:30. So if any one of you have any more comments, please do so before we end the session.
Okay. So we thank everyone for joining us for this session. Maybe I will just make a proposal here, see whether our group agree. Hong Xuan, is that maybe when the China, the Tianwen probe is close to Mars, to Mars, maybe in January, they are going to enter into the orbit around Mars. We have another discussion. And later on, in February, successful insertion into Mars orbit. That time we have another discussion. And the Mars lander land on the Mars, what you call in April 23rd, another discussion. And then after lander successfully, the rover, Tianwen rover, hopefully got name log, you come down from the ramp, the first footprint on the Mars, another discussion like this. Yeah.
Actually,
Yeah, I think that would be great, and maybe for the Perseverance mission, we can conduct
Also
this kind of discussion as well.
Yes.
Yep.
Yes.
yeah, we can actually conduct such discussion for Perseverance mission lah. But then we not necessarily to break up to so small part. We can actually combine into a bigger one, so that we have more things to
like
discuss
updates, I
and
think.
more interesting topics. Yeah.
Of course, I remember I followed
I
the
think maybe
curiosity mission. The NASA explained that Curiosity is an autonomous robot. Curiosity was the most advanced robot built by man, because of the delay in the radio communication with the Earth. So the Curiosity must work by itself. So I'm sure Perseverance will definitely the most advanced robot built by man, more than 1 ton. And just to explain the Perseverance will take the whole night. A lot. You saw the arm, very impressive, And maybe also want to read more information of that Ingenuity helicopter, the first powered flight on another planet. The first powered flight. Remember, all the flight is by parachute law, by retro rocket, landing on Mars law, landing on the moon. But this is the powered flight, independent flight. You see. So just one more detail, Hong Chuan, is that I have a feeling that when the lander, we have, for example, you have the heat shield, we have the aero braking, the heat up the heat shield, then heat shield drop off, then the parachute open, and the last moment the retro rockets will fly. I have a feeling that the retro rockets will not only allow the Chinese lander to land vertically, but can move X and Y horizontally. In case the parachute want to release the lander and the retro rocket start firing, and at that time the lander is over a big rock, over a steep slope. So definitely the lander must move able to move horizontally many meters. Then it will, if the intelligence built inside it, the program said that okay, now we move from this steep slope to a flat portion, then only we land. So that means the retro rocket is not only to break the rocket, but must move sideways also. I think it must be like this.
Yeah, I think I read some 1 or 2 sentences about this. I think this should be true in a paper. Yeah, so maybe we can call it an end. So for those who are interested for the coming updates, please subscribe to our YouTube channel. And if you are one of our members, please take notes and be aware of our future updates in our member group. So thank you everyone for listening for the past 1.5 hours. So see you next time. Thank you.
I think we can end the session with the playback of the launch news.
Hong Chuan, you also must announce to them on Saturday, 25th of July, airport session. Coming airport session on YouTube.
So yeah, you're right. So in this Saturday, around what time?
Same time, 8:30 p.m. 8:30 p.m.
It's the same time, 8:30 p.m. So please be aware of our YouTube channels. Any updates of the sessions will be available on our YouTube channel. It's about APOD. APOD means astronomical photo of the day, which will be explained to you by Dr. Chong. So please subscribe. Thank you. So maybe as Light say, we can end our session with a video.
Yes, please. You have a nice background, Hong Chuan. Mars behind you. Very nice. Mars.
Yeah.
I like it.
I'm on Mars.
Yeah. What you should do next time is Mars background behind you, but in front of you, next to your mouth, you hold a rusty iron tin. Rusty one. Behind you is iron rust. In front of you is a rusty can of drink. Okay, YouTube live is going to load. So only 5 days from today will the Tianwen probe pass by the distance of Moon. It's not still very close to the Earth, and it'll be coasting all the way free ride, free energy to Mars. 7-month journey to Mars.
So we'll be waiting for Lice showing of video.
Cannot hear
Is it
live.
better if we share through the SP account, so that, because if I share, then you will see small. If ASP share, it will directly have a full screen, is it?
Never mind lah. Small screen is not my live. You can show on your small screen. It's what? Yeah.
Maybe you just present your screen. That
Present your whole screen lah.
should be okay.
Yeah.
Or a single tap will do.
Present the whole screen. With sound, huh?
So this is a playback.
Yeah. Explain as the video continue. Explain live. Explain
So
what's
this is a no. Actually, I think we can end the session, but we just play the playback, and then if they have any question, they can just put in the comment, and then if we have any, we continue to reply offline, in the comment section.
Yeah, I will inform our technical person, Michael, to end the session after the video playback.
So live you can explain. Don't worry. You can keep on talking when the video is running. If you don't say, I will say.
You all did not hear anything from the video? I thought that no sound.
No sound. I can hear your voice.
How come no voice from the video? No audio.
Yeah, I think this configuration is normal. You have to,
Never mind.
if you want to have sound, you have to prepare a specific tabs, and then you have to tick it up. You have to tick that you will share the audio from desktop. And I think maybe it is better that you send the link. You send the link to the chat session, or maybe I can send it so that everyone can have a look at that instead of looking at a silence video. Is it okay?
That means I send a link in the YouTube comment section, is it?
No, but we want to see here
Yep.
so that we can make comment. You want to see now? Can you play? So let me say.
I thought
So
it's
this
playing. You don't see anything?
I see the rocket. I can see the video of the rocket, but no sound from the video lah.
Yeah,
no
I can
sound
see
from the
that.
So
Yeah,
So
it's a little bit laggy.
Long March 5 is a two-stage rocket. First stage in the inner core, liquid oxygen, liquid hydrogen with 4 boosters lah. And the 4 boosters is also liquid fuel, but the liquid fuel is liquid oxygen and kerosene. First stage. Central core booster with 5 core rocket with 4 booster. And the second stage is of course another liquid hydrogen, liquid oxygen booster. And on top of the second stage inside the fairing is a Tianwen rover, lander, and orbiter. All right, and just before launching, and just now live showed, you see the cable drop out. It's the umbilical cord. The umbilical cord that give now it's launching. And launching.
Off.
And look carefully, not yet tilted. The moment it tilt, it must point towards the southeast of Hainan Island. Why? The rocket must fly over the South China Sea towards the southeast, so that there are no much land people there. You see, like turning left, left means towards the southeast. All right, I can see the four boosters and the central core. The central core, the flame you don't see so well, but the central core also lighting. So there are 5 rockets now pushing the thing up and turning left, flying over the southeast. It's passing by Philippines and Sabah, going towards the Pacific Ocean. And before the first orbit is over, it fly over French Guiana in South America, where the French, you remember Kourou, the ASA launch pad? So there's a radio tracking station that will track the Tianwen. So now going towards the southeast. And we know the rockets are very powerful. Within a few minutes, already supersonic. Okay. Remember, Wenchang is at the northeastern corner of Hainan Island, and this is flying towards the southeast. And they already, before launch, a few days earlier, they warned all the ships in the sea, please don't go there or during launch time. And I'm sure if there's any commercial flight, they also have been warned. Why? Because the first stage booster, the 4 booster will fall into the sea, so it's quite dangerous. And the first stage 4 boosters, when they fall into the sea, are not recovered like what our SpaceX or Elon Musk do. They are not recovered. And it's already supersonic. It's still the first stage. So we wait for the first stage separation and the ignition of the second stage. So it's still the first.
Actually, the boosters is still there. So the first stage will take a longer time.
Yeah. So when the boosters fall off, you see 4 of the boosters separating from the main rocket.
As you will see the flame off first, and then you will see.
Yeah. Why is the smoke so fat, so broad? Because it's like lower and lower atmosphere, like a vacuum there. First stage booster separation. So they will fire the explosive. The explosive will blow and push the boosters away.
Call it the pyrotechnic.
Pyrotechnic means a kind of explosive.
Yes, you see the.
There you are.
The
Four.
boosters fuel finish and then detach from the surface.
So don't let a single of these booster fall on your head. I can smash down the whole house also. The 4th booster cannot be seen. It should be seen now.
It's actually the
4th one can be seen now, separated already.
These are the boosters.
The 4. Of course, the main core. So these 4 boosters are falling down, coming closer and closer to the Earth. The other one, the central core booster is still going up.
The main stage, the first stage still continue, right? First stage.
Yes. And then we are waiting for the core of the first stage detach, ignition of the second stage. This is later. This one, I'm correct. They are pushing the clap their hand. They're so young. Hong Zuan, you see, they're all so young.
Yeah.
You push. It will insert the orbiter, lander, and rover into Mars trajectory.
Okay, so this is the second stage.
Second stage. Those pressurized.
So first stage just ended, and then detach,
Second stage.
then second stage.
Ignition. Yeah.
So now the second stage will start.
Yeah.
The second stage rocket engine will start.
Like, here's a question.
Yeah.
On the second stage, how come they put 2 small nozzles instead of 1 big nozzle?
So they can control a bit on the direction.
I mean, because normally if you have a rocket nozzle in a vacuum, right, you want to have a big nozzle to optimize it for the vacuum chamber. I mean, for the vacuum environment.
Can we could be the thing of cost, cheaper to make two smaller engine than one big engine.
Is it one engine or a single 2-chamber engine?
No, just now we saw the second stage got 2 nozzles. 2 nozzles lah. What I'm saying is, instead of 1 big nozzle, they make 2 smaller nozzles. Maybe because 2 they are detached already. Light detached already.
Yes.
Now inserted into the trajectory to Mars. And from this moment onwards, Hong Zuan, the rocket is slowing down all the time. Slowing down from 41 kilometers per second until just before enter into Mars orbit, 24 kilometers per second. It's slowing down all the time. So it's free ride all the way. The only thing can influence it is the solar wind. The solar wind can affect it, or the sun's radiation pressure can affect its orbit. And of course, if we fly by the moon and the other planets, it can affect the trajectory a bit also. Wow, all very young, very young.
And just a little bit of add-ons. We know that the boosters will fall back to Earth.
Yeah.
The first stage will fall back to Earth. What happened to the second stage?
Yeah. It will enter
Anyone, any idea?
low on orbit lah, and eventually will still fall back to the Earth lah.
Yes, it will fall back to the Earth, but it takes a very long time lah.
There
And
you are.
so
Source cell open already. Yeah.
so if you manage to track all the objects in the space, you will realize there are
That
many
means we
rockets
still
body
can
up
measure.
there.
We still can observe it.
Yes, you can observe, so you can realize there are many rockets body on top. They are basically the third stage or the second stage of the rocket so it contributes to
Many
the
rocket,
space junk.
yeah.
The question, I just got one idea in mind. Is the orbiter towards Mars visible with a telescope? Magnitude 12. In magnitude 12, 13, you can see with our telescope.
You can try whether you all can capture it or not.
Yeah, maybe we can.
What magnitude it is? What magnitude? Is magnitude up to 14, 15, 16, with a telescope, with a sensitive camera, you can capture it.
Yeah, maybe we can check that afterwards. So
Yeah.
maybe we can call it a day,
Yes,
session.
yes.
So
Thanks to everyone.
yeah, thank you everyone.
Thank you to you. Thank you. Thanks to Michael also. Lai and David.
Yeah, thank you everyone.
Thank you,
So
Dr. Chong.
we are end the
Thank you.
Amit, Hong Juan, and our technical team of ASP. Thank you
Yes,
very
yes.
much.
Thank you. All right. Good night.
Right, good night. Have a nice day.
Yeah, sure.
Good night.
Bye.
Bye.
Night.
What's up?